This assessment asks us to synthesize this amide from this alkene. Thinking about it in the backwards or retrosynthetic direction, an amide can be made from an acid chloride, which can be made from a carboxylic acid. We don't know any direct ways to turn an alkene into a carboxylic acid, but a carboxylic acid can be made from an alcohol. And I do know ways to turn alkenes into alcohols, so I can use that to join together the two pathways of this synthesis. So the first step of this synthesis might be to take our alkene starting material and add an alcohol. Now we want to be very careful. I need this alcohol on the terminal carbon of the alkene, the less substituted side of the alkene. So I'm going to use hydroboration, where I start with borane and then add sodium hydroxide and hydrogen peroxide. That takes my starting material and turns it into an alcohol with the oxygen at the less substituted side of the molecule. I can then turn this alcohol into a carboxylic acid using an oxidant like something like Jones reagent. I can use something like chromic acid, H2CrO4. That's usually done in water acetone solvent. And that oxidizes the alcohol into a carboxylic acid. Now I can do my carboxylic acid chemistry. I can turn the carboxylic acid into a acid chloride with thionyl chloride. Thionyl chloride turns the carboxylic acid into an acid chloride. And now I can turn the acid chloride into the ester by adding diethylamine. And diethylamine will take this acid chloride and turn it into the ester that I need. So this four-step pathway can synthesize this amide starting from this alkene.